All right, and finally, we have one last ketone reaction, and I went over this briefly with you guys with the aldehydes, the hemiacetal and acetal reactions. We did that one in class because it's a little harder to explain. This time, I'll do it in the video because you've already seen what this reaction looks like, so it doesn't change that much. There's only a slight difference here. So I'm starting out with a ketone, obviously. So I'll keep it simple and start out with acetone, just as my original thing here. And then I'm going to react that acetone with an alcohol to make a hemiacetal. So remember, all that really happens here is, and you don't need to draw this in your notes again, it's just kind of give you an idea, that hydroxyl group that I have right here is actually going to kind of line up like this so that I can flip-flop some electrons or rotate some electrons around to make some new bonds, because I want to make a bond here and here by breaking this bond and this bond. So I should be able to do the same thing as I did before, and my product then, if I now only have a single bond to that oxygen, this turns into a hydroxyl group, and then I should have this carbon connected to an oxygen that was part of my alcohol. And then since it was an ethyl alcohol, there's an ethyl group attached to that oxygen, so two more carbons over there. So again, and if I give you your reaction prompt for a hemiacetal-acetal type reactions, you should have a carbonyl group, an alcohol, and then you have that acid catalyst, but your hemiacetal would look like that product on the right. I can also react that hemiacetal further to make an acetal out of this. So if I draw what I have so far, right, it gets a little funky because you've got 4 bonds on that carbon, whereas if it was the aldehyde version of this, the only thing that would be different is if I lost this carbon here, because maybe it was just an acetaldehyde to begin with. And so adding that one extra carbon there does make the spacing a little weird, but it doesn't actually change the reaction. But to make an acetal from this hemiacetal, I need one more alcohol. Let's say I have an isopropyl alcohol to add onto this, so that all my R groups are slightly different and we can differentiate and see those things. So same prompt, need another alcohol to do this. But now I'm going to take part of that alcohol, that hydroxyl group, and then take this hydrogen here. Or I could have taken the whole hydroxyl group from my hemiacetal and then the hydrogen from my alcohol. It doesn't actually really matter which one is which. But I'm going to remove those as a water, as a product. But then, again, I'm going to connect this oxygen over here ultimately to this carbon over here, the carbonyl carbon, or excuse me, that's not a carbonyl carbon, but the hydroxyl-bearing carbon in my alcohol. So then I'm going to make a product that looks something like this over here. So I still have that oxygen there. I still have an oxygen with a ethyl group on it. But now I just need to attach an isopropyl group to that oxygen, and there's my acetal. So they are funky looking things, just like I told you guys last time around. But hemiacetal-acetal reactions for ketones, very, very similar to hemiacetal-acetal reactions for aldehydes. So just predicting what would it look like when I put these together, right? A lot of times with my hemiacetal and acetal type reactions, I really do like to give you an acetal to start with. So maybe you'd get something like this, and I'd ask you, okay, break that up into the pieces that it was made from, right? That's an acetal. And I know it's an acetal because it goes carbon, oxygen, carbon, oxygen, carbon. And I know that this carbon right here was my original carbonyl carbon. So you can do this in multiple steps, but all you really need to understand is you have two alcohols and a ketone in here. So when I start breaking this apart, I just have to recognize that, okay, I need water here. In that first step, I'm going to remove one or the other alcohols. It doesn't matter which one, right? And so I'm going to remove this alcohol. And that alcohol only has one carbon attached to it, a methyl, so it must be a methanol, right? So I just draw one carbon that's attached to a hydroxyl group. That's my methanol, excuse me. And then whatever's left should still be there. I got this oxygen over here, an ethyl group off of it. I still have an oxygen here, but it's a hydroxyl group now. So that's the first step. I removed one of my alcohols. But then the next step of the process, I'm just going to remove my other alcohol, which would come from here. And so I need to take off right, that'd be an ethanol, because there's two carbons, and then it's going to be a hydroxyl group, right? And technically, I stole this hydrogen from over here to make that hydroxyl group there, because that was part of that original hemiacetal formation. So I didn't need water this time. But what's going to be left behind, again, is whatever's left. And then it was a ketone. So just, again, if you can recognize what your carbonyl group carbon was from the get-go, this carbon here, right, that connects two oxygens together, still the carbonyl group right here, because I still got two oxygens connected to that carbon. That's the carbon that ends up bearing that double bond to oxygen, and that's where your ketone comes out. So as long as you can identify your two alcohols, right, the methanol and the ethanol, and then you can figure out what part of that was your ketone from the get-go. It's actually pretty easy to split these things up once you get used to it. Right? And you could do this all at once. Right? I usually do it in multiple steps just to illustrate so you can see. But when you're doing it, you can actually just draw the two alcohols and the ketone that would have made up that acetal. So this portion of the work right here, let's go back to black, this hemiacetal that was kind of in the middle, that's not actually part of your answer. I only drew that so that I could show you that I'm going to take off one part at a time. You can just give me the two alcohols and your ketone as products when it's all said and done. So shouldn't be too difficult. You just got to learn how to identify what part came from what.